Hi, and welcome to Complex Numbers Day 2. Today we are going to be multiplying and dividing imaginary numbers and also talking about a complex number. Recall from yesterday we had this little magic clock here that helped us with our powers of I. On the inside of the clock I had 1, I, -1, -I. On the outside it's I to the 0, I to the first, I to the second, and I to the third. And I was just equal to the square root of -1. To find I to the 63rd, we took 63, which is our exponent, divided it by 4. So wasn't there 1, 4, 2, now on your 3, 5, 20. My remainder is 3, so this is equivalent to I to the third, and I to the third is -I. So yesterday we did adding, subtracting. Today we are going to multiply and divide. So the first thing we need to do is simplify the radical. Meaning we cannot just go ahead and multiply underneath the radicals. We need to actually take care of the negative first. So this would become I radical 3 times I radical 12. And when I multiply outsides, so I get I squared. And then I multiply insides, which is 36. Hang on. Okay. And I squared, if we look in our chart, is equal to -1. So it's -1, and the square root of 36 is 6. So my answer is -6. So in this case, it is possible to have a negative under the radical and get a negative answer. Or even just get a negative answer when you have radicals. All right. There is another way to do this problem. We could simplify and do I radical 3, and then simplify my radical as 2I radical 3. And then when I multiply, I get 2I squared. And radical 3 times radical 3 is 3. And then we'd have 2I squared is -1 times 3. We still get -6. And they're both correct. Neither one is more correct than the other. For number 2, the square root of -16 is 4I. The square root of -9 is 3I. So my i's cancel out, so I'm left with 4 over 3. So there my answer is -6. Here's 4/3. For number 3, we can multiply. So 2 times 3 is 6. I to the second times I to the fifth is I to the seventh. And if we go back and use our clock, we start with 0 and 1, 2, 3, 4, 5, 6, 7 is equivalent to I to the third, which is -I. So it's 6 times -I. So it's -6I is my final answer. Or I can simplify my powers of I first. So I'd have 2 times I squared is -1 times 3 times I to the fifth. Well, I to the fourth is 1, so I to the fifth is I. And then when I multiply, I end up with -6I. So in either case, that's your answer. For number 4, we could write it again because I have a squared there. And I'd multiply and I get 25 I to the 8th. I to the 8th is 1, so I just get 25. Or I just simply multiply or take 5 and raise it to the second power, which is 25. And then when you have a power to a power, you multiply, so it's I to the 8th, which ends up being the same. It's just a matter of how you look at the problem. All right, a complex number is written in the form A plus or minus BI, where A and B are real numbers and I is the imaginary number. So in order to add and subtract, first I have to simplify if I can. So this becomes 5 plus the square root of negative 36 is 6I, plus 3 minus the square root of negative 16 is 4I. So combine your real parts. So 5 plus 3 is 8. Combine your imaginary parts. And a positive 6I and a negative 4I is negative 2I. Or sorry, plus 2I. For number 2, we need to distribute that negative under the second set. So I have negative 8 plus 5I minus 5 plus 7I. So again, combine your real parts. Negative 8, negative 5 is negative 13. And 5I plus 7I is 12I. Notice we have in the form A plus BI, so it's the real number and then the I part second always. Multiply and divide. Well, multiply. Here I have a double distribution or a FOIL. 2 times 3 is 6. 3 times I is plus 3I. Negative 5I times 2 is negative 10I. And then negative 5I times I is negative 5I squared. But I squared is equal to negative 1. So this becomes 6. And if I combine like terms, I have a 3I and a negative 10I. So I get minus 7I. And then I have a negative 1 times a negative 5, so it becomes plus 5. So I have 11 minus 7I. Just like we were dealing with radicals, we had conjugates. 1 plus 5I, and its conjugate is 1 minus 5I. I only changed the sign in the middle, remember. So I do FOIL. 1 times 1 is 1. 1 times negative 5I is minus 5I. 5I times 1 is plus 5I. And then 5I times a negative 5I is a negative 25I squared. So my negative 5I and my positive 5I cancel each other out. I squared becomes negative 1. So I end up with a 1 plus 25, which is 26. The whole goal of the conjugate is to get rid of the i's. Number 3, I have 6I cubed. Well, so it's 6 times I cubed is negative I, plus distribute the 2. 2 times 7 is 14, and then 2 times 3I is plus 6I. So this means I have negative 6i plus 14 minus 6i. Well, my 6i and negative 6i cancel each other out. So I have 14 for my final answer. Just like with radicals, I cannot have an I in the denominator. So whenever I have a monomial term with I in the denominator, I simply multiply the top and bottom by I. I do not have to include that number. So I end up with 3i minus 5i squared, because I times I is I squared. And in the denominator, I end up with 2i squared. But we said I squared was negative 1. So I end up with a positive 5. So it's 3i plus 5 all over a negative 2. In a plus bi form, we need to switch it and put it as 5 plus 3i over negative 2. And finally, for the last problem, again, we have to multiply by the conjugate. Because I have a binomial denominator, my conjugate is 2 plus 7i. On the top, I need to FOIL. 1 times 2 is 2. 1 times 7i is plus 7i. Negative 3i plus times 2 is negative 6i. And then negative 3i times 7i is negative 21i squared. All over 2 times 2 is 4. My middle terms are going to cancel out. So I will get negative 7i times positive 7i, which is negative 49i squared. I squared is always negative 1. So I end up with 2 plus I plus 21 all over 4 plus 49. And when I combine terms again, I get 23 plus I all over 53. And they have nothing in common, so I can't simplify it. That is what my final answer is.